My name is Carl Fligger. I'm the Quadro Product Marketing Manager with PNY. I'd like to welcome everyone to the NVIDIA Quadro RTX Real-Time Means Real Change for Cinema and Television Production. Joining me this morning is Rick Champagne from NVIDIA, so I'll let Rick do a quick introduction as well, and then we'll dive right in.
Hi, everyone. As Carl mentioned, I'm Rick Champagne, and I'm the Global Industry Marketing Manager for Media and Entertainment at NVIDIA. I represent the enterprise side of the house, and happy to be here today. Thank you so much for your patience. Carl, take it away.
Really, we're going to start out with a brief overview of the Turing architecture that underlies the Quadro RTX products. We're going to do a deep dive into a lot of this subject matter later, so kind of consider this an appetizer with the main course to come. It is fair to say that overall, Turing is the greatest leap NVIDIA has brought to market since the onset in 2006 of their CUDA-compatible GPUs, which brought general-purpose GPU programming to graphics processor units. It's a new streaming multiprocessor architecture with a high performance bar capable of 16 teraflops floating point operations plus 16 tera integer operations per second with a fully concurrent floating point and integer execution pipeline. It also has a feature implemented called variable rate shading, which allows developers to control the shading rate dynamically and to a large extent decouples the past dependence of prior GPU architectures on CPU supervision. So the GPU can operate more autonomously and through its massive parallelism deliver much higher levels of performance more efficiently due to this decoupling with the CPU. There's also a new core type, RT cores. We could spend a whole hour talking about this. Suffice it to say they are optimized for the needs of ray tracing, handling of data structures, handling of mathematical problems like bounding volume hierarchies, and other things, ray triangle intersections that are intrinsic to ray tracing are now implemented in hardware. At the high end of the product line, up to 10 gigaarrays per second can be realized. Joining the Quadro architecture, not quite for the first time because we do have the Quadro GV100, but Tensor Cores are coming into the mainstream. Tensor Cores are really specialized compute units optimized for deep learning, machine vision, artificial intelligence applications. We're going to talk about those in more detail in a moment. On the display side of things, HDR, high dynamic range, is baked into the design, as is 8K DisplayPort, and a new way to interface with VR HMDs called VirtualLink is also intrinsic to the design. RTX GPUs support a NVLink interface that allows up to 100 gigabytes per second of bidirectional data transfer between cards, and allows you to fuse GPU and memory assets into a single logical entity. On the video front, high-efficiency video coding, 8K real-time encode is also supported. Turing really makes a dramatic impact on professional workflows, and again, Rick will be talking about M&E, but it's the synergistic fusion of ray tracing, deep learning, and advanced shading. The RT cores utilize a hybrid rendering, some traditional raster rendering, but ray trace rendering that really does model the behavior of how light behaves in 3D. It's up to 25 times faster than the previous generation Pascal GPUs and smokes CPUs with up to a 30-fold speed improvement. The Tensor Cores, although they're primarily for AI, have very interesting media and entertainment implications that Rick will dive into. Things like AI denoising, resolution scaling, video retiming will all be covered in quite a bit of detail momentarily. Advanced shaders are also a very important part of the architecture. Basically, variable rate shading is implemented with these products and allows developers complete control over the shading rate so that they can really optimize and tune their applications using VRS to put resources where it's needed, to make applications more efficient, reduce work in regions of the screen where full resolution shading perhaps wouldn't be required. Texture space shading is also available, as is mesh shading and multi-view rendering. Mesh shading in particular introduces dramatic efficiencies and also decouples GPU and CPU interactions. Multi-view rendering is key for advances in VR performance. We have in the product family the RTX line, the RTX 8000, the RTX 6000, the RTX 5000, and the RTX 4000. Literally a new vocabulary was necessary to describe the performance of these boards. The RTX 8000 and 6000, for example, are up to generating 10 gigarrays per second. 10 billion rays can be traced per second. I mentioned the 16 teraflops, 16 tips. Up to 500 trillion tensor operations using the Tensor Cores can be realized. And with NVLink, you can have bidirectional communications at up to 100 gigabytes per second with these cards. Quadro RTX really is the logical evolution of computer graphics. And if we kind of go back to the Urtext, the old days, we had fixed function pipelines. Basically, whatever the hardware could do, the developers had access to. But if the hardware didn't support it, the developers were basically locked out. There wasn't a lot they could do to write software to get around the constraints of the hardware. A significant advance in which NVIDIA led the way was programmable shaders. The example I'm showing here is probably one of the best examples of what I call and industry folks call the uncanny valley, where an image looks almost lifelike, but it doesn't quite look lifelike enough. Some people don't mind this. Some people get really creeped out. But basically, programmable shaders, using languages like C# or high-level shading language, allow a huge improvement in realism across media and entertainment, but still didn't meet all the needs of M&E professionals for final rendering and enhancements were needed. With the onset of CUDA, compute came to Quadro and NVIDIA GPUs. The graphics was already there. Using these two together, though, can be extremely powerful in an M&E context. The image you see here is of a ground-based explosion. And if there's anything we know about blockbuster movies and TV, they like to blow things up. Well, prior to the ability to simulate this kind of thing, an artist would have needed to draw it. And unless that artist had some kind of inkling of the physics involved, what they came up with may not have looked terribly realistic. This is a graphic that was actually generated using CUDA simulation and then rendered by Quadro that is completely realistic physically. So the ability to bring simulation into the mix can be a huge time saver rather than force animators or other digital artists to try and create these effects from scratch. More recently, artificial intelligence, techniques like AI denoising for rendering have allowed huge improvements in rendering throughput. The left-hand side of this scene shows kind of a grainy, sandpapery look. The right-hand side has the AI turned on. In as few as 10 or 12 iterations with the AI-enhanced ray tracing, you can get what looks like a photorealistic image. With RTX, the addition of the RT cores and their fusion with some AI functionality in the Tensor Cores and a new hybrid imaging model, we're finally able to realize real-time ray tracing. And NVIDIA has brought this to market about 5 years before industry experts in general thought it would be available. And again, Rick will be doing a deep dive on the implications of this for M&E momentarily. It's important to note that RTX rendering and RTX is more than just some Quadro cards or a Titan RTX or perhaps even some GeForce cards. An interesting statistic about NVIDIA is they actually employ more software engineers than hardware engineers. So RTX technology is also a software stack. You have the RTX hardware. On top of that, you have a new highly optimized rasterization graphics pipeline. You have the RT cores we've discussed. You have, of course, compute, which CUDA in its 10th iteration is available. And you have the new AI Tensor Cores. On top of that, you have hooks into frameworks like optics, or APIs like Microsoft DXR, or emerging graphics APIs like Vulkan. On top of that, you have the materials definition library that allows a user community such as M&E professionals to define a variety of different materials and imbue in that library all of the physical aspects that need to be taken into account. For example, subsurface scattering comes to mind. China would be an example of that, where a light ray hits it, some of the light's immediately reflected, some of it penetrates and is then reflected back or scattered. From Pixar Animation, USD, Universal Scene Description, was also utilized by NVIDIA and made available by Pixar. MDL was open sourced, by the way. USD basically gives a way to encapsulate the geometry and other parameters of a scene to make it more portable. Of course, on top of that, you have applications or plugins. You have a variety of NVIDIA SDKs and tools to help ISVs optimize their applications for RTX hardware. The RT cores really will make a huge difference in productivity. The primary benefit is real-time ray tracing in the application viewport. So the tools that M&E professionals are using day in, day out, Maya comes to mind, 3ds Max comes to mind, a whole bunch of GPU-accelerated renderers come to mind. Real-time ray tracing is available for the first time. Other tasks such as offline rendering, which may be necessary, for finished rendering before it's sent to a digital file for distribution, can also be dramatically accelerated. And while a creative professional is sitting in front of a workstation with real-time rendering, they have the ability to explore additional iterations, additional design ideas, creative concepts, which allow them to present to their colleagues or to directors or producers a wider array of creative choices to further propel the future and the sophistication of digital storytelling. NVIDIA Turing Tensor Cores are really specialized execution units designed specifically for the tensor matrix operations that lie at the heart of deep learning. Now, they're similar to the Volta Tensor Cores introduced in the GV100. However, the Turing cores offer tremendous speed-ups for matrix computations at some other positions, such as int8 or int4, in addition to FP16. The Turing Tensor Cores bring new deep learning-based AI capabilities to Quadro, and NVIDIA, of course, is delivering developer tools and frameworks, and you'll see the fruits of this benefit. But the convergence, the nexus of if you will, of ray tracing and AI is really enabling tools that will save creative professionals in M&E a lot of time, allow a lot of money, economies to be realized as well. And the Turing Tensor Cores, being a second-generation implementation coming after Volta, have been optimized even further for fast training and extremely fast inferencing performance. The advanced shaders, I've touched on a couple of points here. Mesh shading allows for extremely complex geometries and eliminates CPU call bottlenecks that in the past kind of hobbled the GPU. So it basically allows the CPU to do what it's good at while unleashing the full parallelism that's inherent in the Quadro GPUs. Variable rate shading is extremely important because it allows a developer to basically place the GPU's horsepower where it's most needed. Some examples of this, for example, are foveated rendering if you're a VR user. The fovea is the region of the eye that is most visually acute. It can focus its efforts there and ignore peripheral vision. It can also be used for effects like motion blur. Texture space shading, decouple shading from the screen space. It again improves efficiency and reuse of geometries. It's another feature that's also quite useful for VR. And multi-view rendering extends the abilities of the single-pass stereo, which was introduced with the Pascal architecture, and makes it even more sophisticated, more flexible, more efficient. In the VR space, a lot going on. I talked about the variable rate shading. It can be used to match lens optics because different VR head-mounted displays have different optical parameters. So having the software know what they are and have it tune itself to their performance is a very important capability. The foveated rendering is another one because it puts the detail where it's most needed. And with eye tracking technology, it's context sensitive to the activities of the user. Single pass stereo 2.0, as I alluded to, builds on Pascal, makes even more efficient use of the GPU, can provide 4 independent views simultaneously, and provides a field of view analogous to that of the human eye, unlike prior generation, headsets that kind of limited the field of view. It wasn't quite up to what you're able to see in the real world. Also, VirtualLink, which is built into the RTX products, is a new way to interface VR HMDs into RTX products. This is an open industry standard backed by a consortium, which includes NVIDIA, Microsoft, major HMD vendors. I like to, somewhat tongue-in-cheek, say it makes VR a little less Borg-like. Instead of having multiple cables right into a headset, a single cable provides power, data, and video. Utilizes a USB-C alt mode connector. We'll discuss this in a moment. But basically, easier VR setup, reduced cabling. With the hybrid rendering model that uses ray tracing, optimized rasterization. VR cores, by the way, are also ideal for physically based audio, directional audio, extremely high performance. I've touched on some of these features, but the visual quality is enhanced, the field of view is enhanced, the acoustic simulation is enhanced, and with VirtualLink, easy setup is a single cable away on the RTX products. And here's an example of what that looks like. I'm showing the back of what could be either an RTX 8000, 6000, or 5000. In addition to the 4 DisplayPort 1.4 connectors, you see a USB Type-C. This is a VirtualLink port, and again, it's an industry standard that uses the Type-C connector to give the power, display data, motion tracking sensor data that are required to drive a VR through a single cable. It provides 4 lanes of high bandwidth HBR3 DisplayPort, USB 3.1 Gen 2 super speed support, and up to 27 watts of power. NVIDIA, Valve, Oculus, AMD, Microsoft, others are all on board with this. One very important feature, by the way, is Quadro's going to be offered with RTX BIOSes that disable VirtualLink. So if you're in a setting where you've got intellectual property, you're trying to really keep a lid on what you're working on. A USB Type-C port on graphics card could be viewed, as a great thing for VR, but possibly a security vulnerability. In Quadro, you can plug that hole. GeForce doesn't have that capability. If you'd like to learn more about VirtualLink, visit virtuallink.org for additional information on it. Another very important feature of RTX is it offers the kind of memory required for professional VR applications. The RTX 8000 has an unprecedented 48 gigabytes of GDDR6. If you use NVLink, effectively it's 96 gigabytes. The RTX 6000, 24 gigs, with NVLink, 48 gigs. The RTX 5000, 16 or 32 gigs, the RTX 4000, 8 gigs or 16 gigs. Yes, there is a Titan RTX card out there, but again, in terms of things like where it's designed to be used, what it's designed to be used for, the fact that it uses GeForce drivers as opposed to Quadro drivers, really isn't the optimal card for professional VR applications. And boards like the 2080 Ti or the RTX 2080, which are fine gaming cards and do a great job with, games that require virtual reality. The fact remains gamers can still cut down on fidelity in play. Professionals need absolute and full data fidelity to make the right decisions and produce the best output for their clients. I alluded to NVLink being intrinsic to the RTX product line. It's important to call out that there are a couple of different bridge options. and bridges offered for the RTX products. One thing you need to take into account is different motherboards may have slightly different spacings. So we have NVLink available for standard 2-slot spacing motherboards, or those with a little wider spacing, which require the 3-slot iteration. The RTX 8000 and RTX 6000 share an NVLink connector, which offers up to 100 gigabytes per second of bidirectional communication. The RTX 5000 supports a different NVLink connector, which supports up to 50 gigabytes per second of bidirectional communication. Unlike the prior generation Volta product, GV100 or the GP100, only one NVLink connector is required for the RTX products. The prior generation boards required 2. This is a fair moment to point out that the RTX 4000 does not support NVLink. From the display capabilities point of view, 8000, 6000, 5000, 4 DisplayPort 1.4 connectors can drive 4K, 5K, 8K displays. If you're driving 8K, 2 displays can be driven at 60 hertz refresh rate. You also have the VirtualLink port available for VR HMDs. All of these cards are compatible with the current Quadro Sync 2 card. They can synchronize up to 32 displays from 8 GPUs. And NVIDIA Mosaic support currently, as of today, can scale 4 GPUs across 16 displays. In February, we'll have software for Windows that will support 32 displays. And it works with unmodified off-the-shelf applications and gives you access to a variety of NVIDIA Quadro-only technologies like warp and blend and bezel correction for those that are in the M&E live event space or perhaps doing virtual sets or on-air broadcast work. These can be important considerations. The RTX 4000, you see the backplane here. Here we have 3 DisplayPort 1.4 connectors and a USB Type-C port, which is VirtualLink, but can also drive a 4th DisplayPort display via a USB Type-C to DP 1.4 adapter. And again, in terms of capabilities, the resolutions of the displays, the refresh rates you see, same as the 8000, 6000, 5000. And this card also supports Quadro Sync 2 and essentially provides the same functionality as the other cards in the RTX lineup. That said, I'm going to pass the baton over to Rick. Rick, go ahead and start talking about the M&E implications of RTX, and when you need me to advance the slide, just say next, and I'll go ahead and do so.
All right. Thank you so much, Carl, and thank you, everyone, for joining us today. Really appreciate your time, and I'm just going to go ahead and get started with media and entertainment. So I'm going to jump right in. Carl, can you go ahead and move forward? All right. So media and entertainment at NVIDIA really spans across a few different market segments, starting with broadcast. And broadcast, as an industry, relies on NVIDIA technology really for mission-critical live production. And this is why they choose Quadro predominantly. And so on-air graphics, virtual sets, delivering anything like the weather, dynamic content, all the way through to documentary work, special interest pieces, and more. So things that they do in the edit bay that may show up, a month through production. All of that is part of what broadcasters do, of course. And so they use NVIDIA GPUs for everything from edit to on-air graphics, but also they love the dedicated silicon on the boards because a lot of people don't know this, but there is that encoding and decoding, we call it NVENC, NVENC, and that's really used for encoding, decoding video from many different formats. So they may actually be just using GPUs for streaming out video to different markets in different formats. The next category over is film and television, and this is really different from broadcast television in this sense. Think of like a film production pipeline. So television is more like long and short form episodics, like what you'd see on HBO or Netflix, like Stranger Things, Game of Thrones, Jack Ryan. Any kind of television show that's produced in a similar way to film is what we're talking about here. And NVIDIA has been powering the film industry for a very long time, as many of you know, any Oscar winner in the visual effects category for the past decade has used NVIDIA GPUs in production. we have very strong loyalty in this market because of the world-class engineering work that goes into the GPUs and the software ecosystem, including best-in-class drivers, software development toolkits, software certifications, and Carl will go into some of this a bit more detail later. But we also partner very closely with the industry. We've been working side by side on projects for well over a decade now, and RTX is really a large part of the culmination of that work. So we're definitely very grateful to the industry and love to contribute back all the time. And so that's why we released the world's first ray tracing GPU at SIGGRAPH last year. Then finally, on the far right, you see the advertising market. The advertising market also includes film-like production pipelines for commercial work. So think of Super Bowl work, for example. They do animation, VFX, advanced post-production in a lot of those cases. And in fact, the film and television companies might do high-end advertising, if you're not in one and didn't know that, as part of their complete service offering. And so this market also has a strong need for RTX rendering, for rendering everything from commercials, of course, to motion graphics for advertising. And graphic designers and illustrators more and more now are starting to transition from 2D to 3D workflows to get all the benefits of being able to move things in real time, change an angle in a scene, even if it's a product packaging type of project that they're working on. There are huge benefits that they gain from being in 3D. And so RTX will play more and more of an important role for them too. So AI, of course, is the future of advertising, and you know, in this case, it's everything from data analytics to ad targeting and retargeting, and just being able to become much more efficient at selling through online ad inventories, being able to predict everything from what the person that's viewing this web page might be interested in, through to where they're located, weather outside, any kind of details that can really help target advertising much better to those people. So what we're going, Carl, if you want to skip to the next slide, we're really going to cover four major drivers of the industry here. And so we'll talk about 8K video, GPU rendering. There's a tie-in there. Of course, real-time ray tracing is, think of this as a little bit different in the sense that this would be something that would be more like game engines. If you've seen recently the Weather Channel's videos, they're doing some incredible work with real-time graphics on set. And so if you Google search Weather Channel storm surge, you'll see a perfect example of how they're using real-time graphics on set. And then, of course, AI and how that's changing the industry. So Carl, we'll just skip ahead, and I'll start with ray tracing. So let's keep going. So those of you who aren't too deeply immersed in 3D yet, ray tracing is a computationally intensive rendering technique for simulating how light travels through 3D environments. And so ray trace rendering allows animators and photorealistic digital assets like visual effects in movies, animated characters in games, and all of these different scenarios. Ray tracing brings accurate lighting, shadows, materials, reflections, and reduces guesswork for artists. It simulates everything from light bouncing off of a surface to traveling through a glass, and if there's water in the glass, how the light ray will travel through that and cast different artifacts like caustics onto a surface. All of that has to be simulated and definitely very computationally intensive. So next. And so NVIDIA has been working with our partners to incorporate RTX technology into their renderers. And one of the first companies to do so was Autodesk with the Arnold renderer, which is currently in beta. And we've been showing this publicly if you've seen the demos. But Arnold is the default renderer for Autodesk Maya and 3ds Max, which are the most popular animation software packages in the media and entertainment world. And to date, Arnold has only used CPU for ray traced rendering, but with the new RTX acceleration that's currently in beta, Arnold is rendering significantly faster with the help of the Turing GPU and architecture, along with the RT cores that Carl talked about a little bit earlier. And so this is really a game changer for artists. They can make changes to lighting, materials, environments, and see accurate results instantaneously without waiting. And then not only are we using RT cores to accelerate rendering, but we're also using the optics denoiser to do on-the-fly denoising using AI. And we'll show you that in a minute. But CPU denoising in Arnold can only be done in batch post-process, leaving CPU rendered models noisy, inaccurate, and not quite so interactive. So we're going to show you that in the next slide here. So Carl, you want to skip ahead? So when artists are done working with their models, they need to show a customer or a supervisor a preview. And this typically they may send this to a render farm and then get a result back and show them later. And so they may plan ahead. But yeah, great if you can play that. But what you're seeing here is on the left-hand side you have the CPU, and then on the right-hand side you have GPU rendered. And so in the time span that you're seeing a single frame being rendered on the CPU, you're seeing an entire turntable being rendered on the GPU. And so that's, you know, a big deal to an artist, particularly if you have a client attending a session, they want to see some changes in real time. You can go ahead and do that, or you can, rather than share a single frame, you can share an entire turntable at that same meeting. So this could be the difference between getting the approval you need to move on with the next phase or not. So we're really excited by this. Our customers are very excited by this, and just really looking forward to this becoming standard in the industry. And so next. And so, of course, there's, in addition to interactive rendering at the desktop, there's also rendering on the farm. And so, you know, sometimes if you're doing something super high fidelity, super high frame rate, you're doing an entire animated sequence, or, you know, in some cases, if you've seen Pixar movies, some of those frames take upwards of 50 hours per frame to render. And so when it gets that computationally intensive, you might go to a farm. And in this case, what you're seeing is to complete the same workload, you're looking at a quarter of the cost with GPUs, a tenth of the space, and 1/11 of the power to power the same workload in terms of rendering. So once again, we're just super excited by this, and looking forward to this also taking off. And what you're seeing here is, next slide, is the RTX server is powering this farm. And an RTX server, you know, on a one-to-one basis, you saw there were a lot of racks of CPU servers. Those are dual CPU servers when we did those comparisons. And based on actual data from our customers, where we got a lot of data on, you know, what does a real render farm look like? And so they're dual CPUs, typically 18-core Intel Xeons, and then they have, you know, a hard drive. They have RAM in there, you know, sometimes 128 gigs of RAM, 500 gigabyte hard drive, something in that range. And then, so we did a similar compare. Of course, a single GPU RTX server like you're seeing here would be much more expensive, but of course the workload is much greater. So what you were seeing in the previous slide is when you balance out the workload across those servers and the RTX servers. But basically here you have 8 GPUs in a single server. You can do this with the RTX 8000s or the RTX 6000s. And when you NVLink the RTX 8000s together, they each have 48 gigabyte frame buffers, but you can get up to the 96 gigabyte scene on an NVLinked pair, which covers a little over 90% of the general use cases for rendering. Typically, a film company would do multiple passes, and in the case of VFX, they're not rendering an entire scene in one go. They're rendering either a character, an object, or different pieces of the plates that they need, and then they recomposite later into Nuke or something like that. But so yeah, the other benefit of this RTX server is that When you're not using it to render, you can also use it as a virtual system. So you can remote with it and run other tasks on it. Next, Carl. All right. And if you want to learn more about some of the rendering with Arnold specifically, we did a deeper dive. Recently, we did a webinar with Cinesight, fantastic studio. They did 215 shots for Avengers Infinity War. And if you remember at the launch, if you watched Jensen's keynote, our CEO, he had a Spider-Man asset up there. That was one of the shots that Cinesight did. In this webinar, they talk about how they got set up with RTX and Arnold and the beta, and they give you real-world feedback, on how that process is going for them. And then, of course, we had Autodesk also present on Arnold and the current state. So that was a webinar fairly recent. So if you wanted to go to the NVIDIA website and register for that, you can watch it on demand. Next. So I won't go through all of this because it would probably take too much time at this point, but what you're seeing here is a typical VFX film production pipeline, and rendering happens throughout the entire production. Carl, if you just go to the next slide, I'll get straight to it. So we look at rendering as a continuum. There's rendering that happens even right at the beginning during the concept phase. You may have some 3D concept art, but you may also have previs and be doing some virtual production using a game engine. And so in that case, we're talking about real-time ray tracing in engine, and that is a way to increase the fidelity of what you're seeing in previs and also in virtual production. But as you saw earlier, there's also interactive rendering. As you're building your model, you want to render it and see it in real time and denoise it very quickly so you can make creative decisions as you're working. Later into the process, as you're getting into lighting and look development, you may be wanting higher and higher fidelity, and that's really where we're talking about RTX server and something that you might send to the farm and do those renders. Instead of 50 hours, you may do it in a fraction of that, of course. But so rendering happens throughout the entire production pipeline. And again, I'd encourage you to check out the Arnold webinar that we did recently. So, Carl, let's skip to AI, and we'll go straight into it. And so AI is also on the horizon. And so there's a lot of repetitive work that happens in production. And there are new ways for us to help accelerate that so that artists can really spend the time where they want to, which is focusing on the creativity and the nuances and adding, if you're doing animation, it's just adding that extra element of human touch, giving that character the little extra expression. It's really focusing on those tasks that the artist would, can help develop their work even better. And so AI will help them get to a point in the process that's much closer so that they're really focused on creative. And so a lot of this, what you're seeing here are just some examples. I'm going to go into these and show you some videos here so that you can really understand these. So Carl, let's just jump right in. We've announced something along with the RTX platform called NGX. It's short for Neural Graphics. And this was a way to help app developers integrate AI technology. And so we built an AI platform that is an all-in-one solution, and it can create and train artificial intelligence models. It can deploy neural networks through our NVIDIA driver, and it provides an SDK for integrating features into creative applications. And so in this case, you're seeing that's AI in painting on the left-hand side. I'll show you an example of that. The network is trained and optimized already for you, and then it can install into other applications. And so NGX, think of it as our plug-in port for the deep learning pipeline. So you can add AI features to applications like Photoshop or Premiere Pro or anything like that. So let's show some examples here, Carl. This is an example of super resolution. And so typically you would see something on the left-hand side. This is taking low-resolution images and using AI to automatically generate high-resolution version. And so there are alternatives like bicubic interpolation that can minimize pixelation, but AI SuperRes on the far right, you can see does a much better job at maintaining details like the reflection in the cat's eyes or the smooth lines in the hair and the eyelashes and so on. And so this feature is particularly handy, even for things like taking your old HD footage, making it 4K, or even SD footage and making it HD or 4K. So this is a great feature not only for images. If you're doing client work, you get pixely logo. You can use AI to try to get as much out of it as you can before you raster or before you vectorize it. So all kinds of different uses for AI SuperRes, and that's available on our NGX website. Let's skip to the next one. The next one is AI slow-mo, and if you want to go ahead and play that. So NGX can also take, say, 30 video that's 30 frames per second, and of course on WebEx it's a bit choppy, so you won't see the smoothness of this. But in fact, what it does is it generates additional frames to provide really high-quality slow-mo or retime footage. And so, yeah, it's definitely not showing properly here. But it's not interpolating frames. What it's doing is it's inventing new frames, which is why with AI you can get a much smoother slow-mo result than you would be able to otherwise. So again, this would be super handy for if you're doing, taking old footage from, say, sports that you were not shot at super high frame rates and you wanted to do a slow-mo. This is the kind of thing that would really help with that type of process. Next. Here we have AI in painting, and so what you can do here, and if you just go ahead and play it, is you can remove unwanted objects from a scene, and then it fills it in with a realistic looking background. What you're seeing here, so, I wrote a magician, not a healer. It's not like a healing brush. It's not taking neighboring pixels in any way. What it's actually doing is it's been trained, it has a neural network, and it's been trained to fill in detail from that network. And so, for example, as a creative tool, what you could do here is, let's say you had a human, you had a close-up of some eyes, and you wanted to, just paint out those eyes. Instead of taking neighboring pixels and just making, removing eyes completely, what it would do, it would infill it using the neural network with other eyes. So it's another great way of getting alternatives and doing creative work. So so that's just an example of what AI in painting does. Next.
For now.
So RTX is helping to accelerate AI inferencing in a lot of top creative apps. And the examples I showed you, and the apps aren't shown here, but those are actually plugins for Photoshop or Premiere Pro. And so, but we've also worked with a lot of other partners, and these are just some examples. In fact, for the super resolution, you see here DaVinci Resolve, they have their own super resolution called Superscale that is AI-based, and you can actually see that working today. So let's go ahead. Oh, and those other cases are renderers. So what we're really talking about there with AI is the denoiser is using AI to remove the image. Okay, Carl, let's just jump straight to 8K. Next slide. And so at CES this year, you probably heard a lot of news. Go back one. You probably heard a lot of news about 8K HDR TVs. There are a bunch of them that released. There are reports now predicting sales of up to maybe 7 million, I think I saw, in the next few years, TVs entering the homes. And so that's quite exciting. But of course, there are greater reasons today for using 8K, and people are shooting in 8K, but really they're doing that to finish in 4K. And here's just a couple of examples right away. So you see there's an 8K video shot there. If you're going to finish in 4K, you can really use all of that extra resolution to do additional like multicam shots. So that was shot once, and then you can zoom, you can pan, and do that. Of course, you can also get higher quality video. So if you're shooting in low light, you shot and you shoot at 8K, when you down-res that to 4K, you'll lose a lot more noise than you would otherwise. You can also use the additional resolution for stabilizing your video and so on. And so we'll skip to the next, and I'll show you a couple more examples here. So, as I was mentioning, you can crop, zoom, downscale. You can also stabilize. And this is just showing you 8K and 4K. Next. But let's say you also want to pan across a scene. You're shooting in HD, so you can use resolution for all kinds of different. You can be actually creating shots right there on the single video that you caught. If some of you saw what Red and Facebook also announced, they showed a 360 camera where they had this amazing demo where they just shot once the entire 360 scene, and they had actors coming in and out of the scene, and basically they shot the entire finished product with a single shot, and it looked like they'd shot it with many cameras. So
use a regular full-size.
Let's continue on. Okay, so if you're working with 8K, high quality, like a high quality red digital cinema camera, dealing with that has been massively intensive. And so in order to get the highest quality, red cameras actually capture the raw sensor data, plus they use metadata. So the camera doesn't do any processing on the image at that point. You're getting everything that the sensor can capture. And that gives the video editors maximum flexibility. They can tune and refine their color, whatever it is, lighting, and then the camera then compresses the footage into an R3D wavelet format. And then when you play back the R3D wavelet format on a PC, the video needs to be decoded at about 200 megabytes per second, and then debayered and translated from a raw sensor format to a digital RGB image, then white balanced, color converted, tone mapped. It's all a really expensive process in terms of compute. So, so let's go to the next slide. And so today, the debayer and color steps of processing red video are now GPU accelerated. We work very closely with Red, and,
there was an update
so
year, right?
GPU accelerated the decode step as well using CUDA. So really, now that we've worked with Red to also offload the decode onto the GPU, we can actually play back in real time 8K footage at full res at 24 frames per second. And so now you can have full res preview, editing, color grading in real time. And so that's quite significant. And when you compare this to a high-end Core i9 processor at 4.5 frames per second, or a 36 core at 11 frames per second, you're still not quite getting there. And so our 8K red playback is supported on the Quadro RTX 6000. And Carl, this is my last slide here before I turn it back to you. Onto the next one. So real-time red video acceleration really gets rid of the need to convert to a lower resolution, as you saw in the previous slide, so you can work at full res and really see the detail that you want to get to. And then, of course, alternate format, no need to do proxies, basically, which also adds time and reduces accuracy.
Oh, the one that they push down.
And so also GPU acceleration means that there's no need for the dedicated processing hardware like a $7,000 Red Rocket X. So for anyone who wanted to know about the difference between Quadro and GeForce, so there was a question earlier from someone, can GeForce also do the rendering that we were showing? And the answer, of course, was yes. They're very capable cards, very powerful, both on the Titan end and the high end of the GeForce line. Of course, there are some significant differences between the two branches, and so GeForce is really tuned for gaming, and the assumption is someone will finish a game fairly quickly, maybe spend 40 hours, 60 hours, depending on the game, and then move on. And the drivers are really tuned for games. They also change more frequently because new games come out. Quadro really is tuned for professional applications, so across manufacturing, media and entertainment, architecture, engineering, construction, so on. And the assumption, of course, is we work with the software vendors to do certifications of the top software applications, and we do this we have over 70 partners that we do this with, and so the drivers are not only certified, but they're tuned for those applications. So where you may see an overclocked GeForce GPU that might seem faster, in fact, when you run it on a certain application, it is not, and so Quadro will actually be considerably faster. So again, tuned for professional applications, not tuned for gaming, and vice versa. And so that's one key difference. Of course, there are advanced professional features in Quadro specifically. There's larger frame buffers, so you can get 48 gigabyte frame buffer if you're doing large scenes, you're doing VR, you're doing rendering, and then, of course, NVLinking them to get up to 96 gigabyte frame buffer. You really get that, and it's ECC memory. There's also GPU Direct for video. There's multi-GPU support, and you can do quad buffered stereo, Quadro Sync, Mosaic. So if you're doing large multi-display walls, for example, all of these types of features are built into Quadro because, again, there are different assumptions made on the use case for how people are using these products. There's also scalable performance here. I already talked about multi-GPU and scaling up to 96 gigabyte frame buffers. The drivers are also longer life, so you can have drivers that run you the entire length of your project. In the case of film or television, you may lock down on a set of drivers for a production that you're doing for 6 months or that you're doing for 2 years if it's an animated feature. And so, and the other thing is that there's also a long life product life cycle, and so you can still buy that Quadro RTX that you purchased to run the production, and let's say in a year and a half from now, you're scaling up to finish the film, you can still buy the Quadro that you bought to start the project so that you're maintaining consistency across the entire thing. This is the same is true in other industries where you have longer life projects that you're working on. Talked about the certifications, over 100 applications, correction there. And so major system builders also do that. So depending on if you're using workstations from different OEMs, you may actually, they do their own certifications as well for whole system design. So that's another benefit. There's also IT manageability, which is critical if you're deploying a large number of workstations or servers that have NVIDIA GPUs in it. So you can have diagnostic tools and monitoring, and you can change drivers on a global setting type of thing. So IT manageability is very important, and that's another major reason why people choose Quadro. There's global support. It's a 3-year warranty, parts, labor, and service. And I talked about extended product availability. And so these are just the top reasons why you see all of this, why professional applications are choosing Quadro. I talked about it in broadcast. There's also a reliability factor. We do not overclock the Quadro cards, and we also test them in data centers so that the cards won't burn out because they're in a tight environment and running constantly, like in the case of a render farm. So many other reasons like that. So people who are relying on these GPUs to make them money want that consistency. They want that reliability. They're all NVIDIA built, and so these are just some of the reasons I just want to go through, and that's because there was a question earlier, and I thought it was relevant. So RTX 4000 is currently shipping, so I think there was a question about that. And of course, PNY can help you with those GPUs. The 4000 is currently shipping, so again, PNY can help you with that. Sure. Yeah, I think it's really dependent on what your goals are. And so if you're in a IT managed environment, then I think the choice is obvious. There's so many benefits. If you're not gaming, and well, even if you are gaming, you can use a Quadro. It'd be an expensive proposition for gaming. There's a better option there, obviously. The drivers are tuned again for professional applications. If you're doing production work, you're counting on this day in, day out to earn your living. I think that that's where Quadro really makes a difference. There's data sets. If you're using larger data sets, Quadro is the obvious choice. If you're running in a data center, if you want to run these at all in a server rack, Quadro is the obvious choice. But again, if you're an independent, you're at home and you're doing creative work and you're gaming, it might be that GeForce is the right card for you. We do see live streamers who are gaming on one system. They want to get full frame rate, but they're live streamers as well, and so they have a second system and they have a pipe between the two. They may be using Quadro to do the live broadcast, but they're using the Quadro to do the gaming. We do see that a lot of GeForce users also have creative applications, and so I think it's a perfectly viable, if cost to performance ratio is the only thing that matters to you, GeForce is the card for you. So, I think that the top 10 or so that we showed earlier really is the case for Quadro. If you're doing a location-based entertainment installation, for example, you have VR running in a mall or in a movie theater lobby or at a theme park, and you are counting on that to be running 24/7, that's Quadro. So, and again, even if you're doing VR with larger, that require the larger frame buffers, there's another reason there. So I think there are some dependencies, but in terms of performance at the very high end, GeForce goes up to the 2080 Ti, which doesn't quite hit the performance levels of the RTX 6000. In that case, you'd have to, if you want to do a match one-to-one in terms of GPU, the RTX 6000 is similar to the Titan RTX in terms of just base performance, not factoring how the drivers are tuned for each. So again, the RTX 6000 would have higher performance in terms of tuned drivers for Maya, 3ds Max, SolidWorks, any kind of professional application for content creation. So,
a couple of other points that could be also relevant here. If you're using projectors and you're projecting onto a surface that isn't flat, Quadro with its warp and blend technology would allow you to customize the output, graphics output being sent to the projectors to map properly on those non-standard surfaces. Another is the mosaic capability that Quadro offers, where you may want to take some off-the-shelf software and scale it over a large number of displays. Mosaic will allow you to do that without having to touch the software. Mosaic isn't available for GeForce. So you may find yourself in environments using projectors. You may find yourselves in environments using hardware synchronization, multiple screens, the ability to span an application across those screens, where the smarts that are baked into the Quadro driver and software stack are simply unavailable on GeForce.
Yeah, that's a great point. And the other one that I didn't mention earlier is that VirtualLink port is a USB-C port. And so, because there are IT manageability features in Quadro, you can also lock down that port, which is really important if you are a film studio and you have certain MPAA regulations to follow for security reasons. You don't want any USB ports on your workstation to be active. You can lock down that port for any kind of government or defense or anything like that. Again, you would want to be able to lock down that port. So some of the IT manageability features aren't very obvious, but in some cases have major implications. So Quadro is really built for enterprise, built for scaling and bigger projects, and for professional applications. So there's you know, it's a core difference between the two products.
Another question that came up, it's kind of trivial after that last one, but important to a lot of the attendees, is when is the winner of the RTX 4000 going to be announced? We're about a week and a half to 2 weeks away from shipping that board. We'll announce in a February newsletter who the winner is. The winner will be contacted based on the email and, you know, phone information that was asked for on the registration form. And in the newsletter, we'll publicize who that winner is. So we'll contact the winner directly, make arrangements to get you the card, and then let the community as a whole know who won the board.
Thank you so much, everyone. Really appreciate your time, and hope you learned something today, and have a great rest of your day.
If you have any questions about Quadro RTX or the solutions it enables that weren't answered in this webinar, try gopny@pny.com. Again, gopny@pny.com. And either I or one of our Quadro field application engineers or one of our sales reps will get back to you with additional information and an answer to your questions. Thanks so much. All of you have a wonderful day, and we really appreciate your time.